Hi, everyone. My name is Charles Stern, and I'm going to speak to you today about Pangeo Forge, which is a Python platform for transforming archival data into analysis-ready, cloud-optimized data stores. We're going to look at a hands-on example using the NOAA OISST dataset. These data are distributed as daily netcdf files, which are organized into monthly directories, and they're accessible over HTTP. We can download a single one of these files with wget and open it with Xarray. And when we do that, we see that a single file is about 16 megabytes in size. Of course, if we wanted to look at a long time series, let's say daily resolution between 1981 and 2021, that would actually represent about more than 14,000 files and nearly 240 gigabytes of data. So the old way to approach working with that data would just be to start downloading it, but that would obviously take a long time. And in the end, we would not necessarily have our data well situated for parallel computation. We're proposing an alternative and what we believe a better way of approaching this problem through the platform Pangeo Forge. And within Pangeo Forge, particularly, we have a package called Pangeo Forge recipes, which defines the logic for performing these data transformations. Here's what a recipe would look like for this NOAA OISST data. It provides a generalized URL, as well as some logic for the time span we're interested in, and ultimately how to concatenate those files in the eventual consolidated data store. So if we import that Python module into this notebook and take a look at some of its inputs, we see that it has indeed formed the necessary URLs for download and assigned them an index in the time dimension along which to concatenate them. Ultimately, a recipe module like this would be executed on what we refer to as the bakery compute infrastructure. That's essentially a cloud cluster a cloud cluster which will perform the extraction of the data from the source HTTP server, ultimately transform those data into a new cloud optimized format and store them in a cloud bucket from which we, the user, can access them. So that computation has already been performed for this recipe. And we see that from this Amazon S3 endpoint, we can then open the entire data set directly without having to go over HTTP for individual files. And in what should be just a few seconds, indeed, we can open up the full 240 gigabyte data set comprising over 14,000 time steps, which we now have loaded into our notebook. And rather than waiting for quite a long time, I think maybe nearly 24 hours for all these data to download, we're now off and running with a performant copy of this data available to us in the ZAR format. So that's probably about all I have to share for the time that we have today, but I certainly encourage you to take a look at our documentation, pangeoforge.readthedocs.io, and reach out over GitHub if you'd like to participate in this project. Thank you for your time.